Can you see it now?
Yeah, I can.
All right. All right. So we are doing calculus AB here. And let's see, this first problem says the graph of a twice differentiable function is shown. Order the values f of 2, f prime of 2, and f double prime of 2 in order from least to greatest, and explain your reasoning. So what is f of 2? Can you see? What's f of 2 equal to?
F of 2 or f double prime of 2?
Oh, just f of 2. What is it? There's 2, right? Yep. So f of 2 is the y value, which is 0. Very good. So yep, that's 0. So what would the derivative be? What's f prime of 2?
Oh,
what does that mean?
I think this graph is actually the twice differentiable function.
Oh, so I'm so sorry. No. No, this is the graph of the function that is twice differentiable. But this is f of x. This is f of x. That's a graph of f of x.
Oh, okay.
Yeah.
I misinterpreted.
Yep. Yeah, I can see where you misinterpreted it. So how would I find the f prime of 2? What would I do to find f prime of 2? Like, tell me what the definition of the derivative at 2 is. Do you remember how it's just the tangent line, the slope of the tangent line? Do you remember that? I think I lost Bailey. Bailey, you there?
Yeah, I just got back.
Okay. Do you remember that the derivative means the slope of the tangent line at that point? Remember that?
Yeah, so you could just use a tangent equation.
So that's just going to be that's just going to be some positive number, right?
Yeah.
You follow?
Mm-hmm.
And what's the double derivative? What does that have to do with? Remember how that has to do with concavity?
Mm-hmm.
So if it's concave down at this point, which it is, see how it's concave down? What would the double derivative be?
That means the slope of the tangent line would be increasing.
Well, but what is the double derivative? Is it a positive value or a negative value at that point?
It would be
if it's concave down. Nope, it's negative. It's a negative value if it's concave down.
Oh, okay. I mixed them up. Sorry.
Yep, it's negative. So what would the order be from least to greatest? What's the smallest of them?
So that would be f double prime, f prime, and then f original, and then f prime.
Got it?
Yeah, thank you.
All right. All right. The next page, do they want you to find dy dx?
Yeah.
Okay. So for something like this is called implicit differentiation. The first thing we're going to do, I'll write the problem out again. The first thing we're going to do is divide both sides by 2. Okay. And now we are going to take the derivative of both sides with respect to x. So we're taking the derivative with respect to x of both sides. So in order to do that, the problem is we have y, which is a function of x. Think of y as some value, like we don't know what it is, but y is some value that has x in it, right? It's some function of x. You follow what I'm saying? So we're going to have to use, in this case, we're going to have to use the product rule, right? So the derivative of, what's the product rule say that we take? We take the derivative of the one, which is cosine of x, times the second, plus the first, times the derivative of the second. But now what we have is we're going to have to use the chain rule for this one, right? Because the cosine of y is really a function of x. So first we have to take the derivative of the outer function, which is negative sine of y, leaving the inner function unchanged. And then we have to multiply that by the derivative of the inner function, which is y. So there's my dy dx. Follow how I did that?
A little bit.
And then that equals the derivative of 1/2. What's the derivative of a constant?
0.
Perfect. Okay. So the tricky part was what I did right here. The tricky part is I'm taking this times the derivative of this, but the derivative of the cosine of y, that would be like me saying, hey, what's the derivative of the cosine of x squared? What's the derivative of the cosine of x squared?
Well, that's 2 cosine x squared, 2 negative sine x squared.
Nope, it's negative sine x squared times the derivative of x squared, which is 2x.
Oh, my bad. I meant 2x.
Right? So it's actually negative 2x sine x squared, right?
Right.
Does that make sense? So that's what I did here. I multiplied it by the negative. Remember, y is like my x squared. I don't know what the function is, but y is some function of x. So I take the derivative of the outer function, which is negative sine of y, just like I did here. And then I multiply that by the derivative of the inner function, which I don't know what that is. It's dy dx. That makes sense?
Yeah, I think so.
Okay.
So then, would that just be...
But now I'm not done, because remember, I'm trying to solve for dy dx, right? So I have to figure out a way to get this by itself.
Okay.
Okay. Gotcha. So what I'm going to do is I'm going to solve this equation now, and I'm going to isolate this variable right here, dy dx. I'm going to get that by itself. So to do that, I'm going to first subtract cosine x, cosine y from both sides. And that would leave me with negative sine x, sine y, dy dx on the left. Got it? And now I'm going to divide both sides by negative sine x, sine y, which is going to give me what? Positive cosine x, cosine y all over positive sine x, sine y. Right?
Follow? I follow almost everything except how you like here. I guess like I understand this part because dy dx is attached to negative sine x sine y, but I guess I don't understand how like it equals this term as well, when like aren't you supposed to like kind of factor dy dx out of it?
No, I'm not factoring it out because there's only one here. I don't have one over here. I only have one version of that, or one factor of that, so I don't factor it out. All I do is I'm isolating this, right? Just like if I had, let's say my equation was, I don't know, x, y plus m, n, t equals 0, and I wanted you to solve for t. How would I solve this equation for t? What would I get rid of first?
xy.
That's right. Just like I got rid of that. I move it to the other side. And then what would I get rid of? mn by doing what?
Dividing.
Yep, because it's being multiplied. So I divide it. That's all.
Okay.
Got it? Makes sense?
Gotcha. I think I had like...
So we're not done though.
Yeah.
Because what can I do with this right here? What can I do with cosine x over cosine y can be written as what?
I think cosine x over y.
cotangent x.
Cotangent.
Remember how cosine over sine is cotangent?
Oh, yeah.
And cosine y over sine y can be written as what?
Tangent.
Cotangent y.
Cotangent. My bad.
That's okay. So there's your answer.
Gotcha.
Okay.
Thank you.
Do you have the answer key, by the way?
Yeah, I do.
Out of curiosity, how did they write the answer? Did they write it as cotangent like that, or did they write it as cosine sine?
Yeah. They wrote it as cotangent xy.
Okay. Cotangent x times cotangent y, right?
Yeah. Sorry, that's
Okay.
what I meant.
Yeah, good.
I shouldn't have abbreviated that specifically.
Yeah. All right, page 3, you got some more questions for me? Or was that it? And now you know everything?
No, I tried and paste it,
Unfortunately not.
Sorry, no.
It's never that easy, is it?
No.
All right, I can't read this super well, so let me see. Triangle ABC is a right triangle with hypotenuse of 150. Okay, find the rate of change of the angle, what's it say? Between one of the legs and the hypotenuse when the opposite
Leg
leg
is 90.
is 90. Okay.
It's
What is the rate of change of the opposite leg? Is it 50 what? I can't read that.
yeah.
So I know that the hypotenuse is 150 and I know it's a right triangle. So let's go 150 and let's make a right triangle and let's hope we're making it roughly the right size. Okay.
Okay. Gotcha.
And it says find the rate of change of the angle. That's where I can't read it. Which angle?
Of the angle theta formed between one of the legs and the hypotenuse
Okay.
when the opposite leg is, I guess we could just say like 99.
When the opposite leg is 99.
I think it looks like either 99 or 93. Sorry, it's kind of blurry.
Okay. Oh, you didn't take a cut. You don't have the book where you took this from?
No, I had a friend send it to me because I was absent the day that we got the
Got
paper.
it.
So.
And it says the rate of change of the opposite leg is in. I can't
Here,
really.
I can type out what I know from that sentence to make it.
Well, you can just tell me what it says because it's okay. I can write it. I just don't understand what I can't tell what it's asking. Find the rate of change of the angle, but what's moving? If it's a triangle, there's nothing's changing. You know what I'm saying? Usually what they'll say is like you have a ladder and it's falling down a wall or something like that. But this just says the right triangle is a hypotenuse of 150 and find the rate of change of the angle made with hypotenuse and one of the legs and the hypotenuse when the opposite leg is not, does it say 9 feet? I can't tell. Oh, is it 15 feet and 9 feet? Is that what it is?
Oh,
That might be it. It might be 15 feet and 9 feet.
Oh, yeah. Yeah, I think you're right.
Okay, 15 feet. The rate of change of the opposite leg is in feet per. I can't really read that. So I can't really answer this question because I don't know we need to know a rate of change. It says, find the rate of change of the angle. But if this is 9 feet, if this is always 9 feet and this is always 15, there's no changing ever going on because that bottom side is always going to be 12 because it's a 3, 4, 5 triangle.
I mean,
you know what I'm saying? But I think what's happening, this is my guess. My guess is this is a 15-foot ladder and it's falling down. And they want to know what the rate of change of this angle is. with respect to this side, maybe. That's my guess at what this is asking. Like, what's d theta? D theta over with respect to, let's call this, I mean, I don't know what we call that. It's technically, it's a y value because it's up and down. So it's like d theta over dy. The rate of change of theta with respect to the change in y. If we call this y. And this is theta. So what they want to know, and what this is, again, my guess, because I can't read the question, but my guess is it's falling down. This is like a ladder, 15 foot. This is like a 15-foot ladder right here. And it's up against a wall and it's falling. It's falling down. I can't make that line any straighter. I'm going to just stop trying. It's falling down here. And so this is the starting point. Y sub 0 equals 9. That's the starting point. But it's falling down. So they want to know what the rate of change is with respect to the height, I believe. Let's see if that makes sense. So we know that theta, what's the relationship between theta and y right here?
They're adjacent to each other.
But what formula could I use? What function could I use to relate this to these things?
Sine, because it's opposite hypotenuse.
Very good. So I know that the sine of theta equals y over 15, right? Because y is the opposite side in this case.
I guess, to be honest, if you want, I can paste it on the next page. The problem before this, it kind of has to do with something more of like a dA over dt, and less with like regular derivatives.
Okay. Yeah. Okay. Yeah. Let's see what the one before it says, and then we'll come back to that one. I can't really read that, so I don't know what it's asking. But it has to, something's got to be changing if they want to find the rate of change. It can't just be, it's a right triangle with a hypotenuse of 15 and a leg of 9, because the other leg is going to be 12 and we're done. And it's not changing at all because it's just a triangle. But what it's saying something about something changing, and I can't read what that says. So I can't make it out. So hopefully the next picture is a little clearer.
Okay, here. I'm pasting it right now. Also, at the end of the problem on like the third slide, it does say the rate of change of the opposite leg is 5 feet an hour. I don't know
that okay. The rate of change of the opposite leg. So this leg right here, this leg is going 5 feet per hour. Is that what you're saying?
I don't know. I guess I'm thinking it would be this one, but
feet per hour. So then this is going to be over time, this is going to be d theta over dt is what they're looking for.
Yeah, like dr over dt, and that would equal 5 over 1.
D theta over dt. So this is dx over dt. Okay.
Oh.
So yeah, so let's use cosine instead. Let's use cosine. Let's see if we can do this one with just this information. So I know that the cosine of theta equals x over 15.
Don't mean to interrupt, but wouldn't the opposite side be this one still? Because
I don't know. All it told me is one of the legs. So I guess we can call it whichever one we want. But it just said one of the legs and the rate of change of the opposite leg. So if they said one of the legs is 9 feet, the rate of change of the opposite leg, we can call it whichever one we want. I guess it doesn't matter, but I would rather have this one be the one that's moving to the right.
Oh, okay.
So here's your theta. This is the relationship between theta and x. This is my x right here. So dx dt, x at the beginning is 12, right? X sub 0 is 12 feet. You understand how I have that? Because they told me at the starting point this was 9 feet. So this is 15, that would be 12, in case we need that.
Oh, how is it 12 instead of 9 again?
Well, this one was 9. They told us that this one of them was 9. So the other one, remember a 3, 4, 5 triangle? This is a 3, 4, 5 triangle. 3 times 3 is 9. 3 times 4 is 12. 3 times 5. Remember that? Do the math and you'll see 9 squared plus 12 squared equals 15 squared. Gotcha. It's just it's a Pythagorean triple. So I'm just pointing that out. So here's my formula. And so we can take the derivative of both sides. So we're taking the derivative with respect to we're taking the derivative with respect to time. So the cosine, what's the derivative of the cosine function?
Negative sine.
Negative sine theta, but then you have to multiply it by d theta over dt, right? Chain rule like we just talked about.
Mm-hmm.
You get that? And then for this one, what's the derivative of x over 15 with respect to time? It would be 1/15th, and the derivative of x is just 1/15th, right? But then it's dx dt.
Mm-hmm. Oh, why aren't they both dx dt then?
Because I have 3 variables that I'm working with. I'm taking the derivative. It's called implicit differentiation. So I'm taking the derivative of these 2 values with respect to a third value, which is time.
Okay.
So I actually don't have t in here anywhere. All I have is related rates, right? Here are the rates that are related to each other. The rate of this angle moving is related to the rate of the side moving. So now now I'm going to plug them in. I already know what this is. This is 5, right?
Okay.
And then let's see. So let's see. So let's plug this in and see if this helps us. So negative sine of theta times d theta dt, which is what they want us to find, right? Rate of change of the angle equals 5/15, which is 1/3. So d theta dt, d theta dt equals, I'm going to divide both sides by negative sine of theta. It equals negative 1/3. And what's 1/sine of theta? What's the reciprocal of theta?
The reciprocal of theta?
I'm sorry, of sine. Reciprocal of sine.
Cosecant.
Cosecant. So the rate of change of the opposite leg, or find the rate of change of the angle. I can't really read what that says, but I think, do you have the answer?
Not for this one specifically. Sorry. I thought he was gonna post it on Google Classroom, but I think it's gonna be when we get back from break
Okay.
for this
So
specific
I
worksheet.
don't know, again, I don't know if I'm understanding this question correctly, but I think the answer is in terms of theta. So I think this is your answer. The rate of change is -1/3 of cosine of the angle. I believe that's the answer if I'm understanding the question correctly.
Okay. If it helps for on slide 4, I did put the first problem before this, which does have the answer to it.
Oh, good. Okay. Can you read it for me? Because my eyes aren't good as it is. And can you read this one? He's better.
Sure, I think so. It
Okay.
says the length of a rectangle is increasing at a rate of 4 centimeters per second.
Okay. So look
And
what I'm doing. Look what I'm doing. So here's the length, and the length is increasing at a rate. So the rate is dl dt. It's the change. D means like the change, delta. The change in the length as the time changes. That's exactly what this means. dl, the change in length as the time changes. Okay, and what did you say it was?
I said the length is, I didn't get to that part yet.
No, you were saying that at a rate of, what's the length changing at a rate of what?
4 centimeters per second.
4 centimeters per
Uh,
second. So that's dl dt. Good. Now keep reading.
Gotcha. Then it says, and the width is decreasing by 5 centimeters per second.
Okay, so dw dt, and it's going to be a negative, right? Because it's decreasing 5 centimeters per second. Okay, and is the area staying the same?
Well, it says find the rate of change of the area, so I don't think so.
Okay, so
Of
find dA dt.
Yeah.
Okay,
Uh, of the rectangle when the length is 3 centimeters and the width is 8 centimeters.
okay. This is more like it. So I think we might have missed some pieces of this problem potentially, or maybe that is the right answer. I don't know. But this is more like a standard problem. So what we're gonna do is we're gonna find a formula, right? Area equals length times width, right? So we're gonna just write that out. Area equals length times width. And now we're gonna take the derivative of this whole formula with respect to time, a fourth variable. Okay, so we're going to treat all of these like functions of time, which is what they are. The length and the width and the area are all a function of time as this thing is moving. Okay, so we're going to do implicit differentiation. What's the derivative of the area? That's easy, right? It's just dA dt, right? Got that? And how do I do when I have a product? What do I do when I have a product?
You do product rule.
That's right. And what's the product rule say? It says take the derivative of the first, right? And leave the second one alone, plus the derivative of the second and leave the first one alone. Make sense?
Okay.
And now all we do is plug in the values. You see how I have all of these values? dl dt is 4. So that's 4. Got it? What's the width?
8.
They told us they want us to know, yep, when the width is 8 and the length is 3. Good. Plus, what's dw dt?
-5.
-5. And what's the length?
That'll be 3.
3. Very good. So dA dt at that instant, at the instant when the length is 3 and the width is 8, the change in the area with respect to time is 32 minus 15, which is 17, and it's going to be centimeters per second. So it's increasing. At that moment, the area is increasing. The rate of change of the area at that instantaneously, is 17 centimeters per second. Tell me that's the right answer.
I will look right now. Yes, yeah, it is. Nice job.
How about that? It's
Nice.
almost as if I know what I'm talking about.
And then after that, it actually does say, also find the rate of change in the perimeter at this same time.
Okay, so let's do the perimeter. How is the perimeter different?
Because it adds up all the sides instead of multiplies them.
Yeah, it's just a different formula, right? What's the perimeter?
2L plus 2W.
So they want to know the rate of change of the perimeter. So dp dt, right? So I'm going to take the derivative of this entire equation with respect to time. So dp dt, it's kind of like I'm distributing that, equals, this is easy, right? Because it's just a sum. So it's 2 dl dt plus 2 dw dt. Make sense?
Yeah, because it's almost, instead of like a chain rule or product rule, it's just like another polynomial.
You got it.
Gotcha. Wait, since it's a coefficient, wouldn't it cancel out?
No, what's the derivative of 2x?
2.
2.
Oh.
So it's 2 times the derivative of L. And what is dl dt?
4.
Good, so that's 8 plus -5 times 2, right?
Yeah, so minus
So
10.
8 minus 10. So -2 centimeters per second. By the way, this is going to be, I made a mistake. This is going to be centimeters squared per second because area is two-dimensional.
Oh, right. My bad. Yeah, I forgot. Yeah, I think you're right for the perimeter too.
Good.
Yeah, thank you.
So this isn't, it's really not that hard once you kind of figure out kind of what you have to know how to do implicit differentiation, but the harder part maybe is finding the formula. You know what I'm saying? That's where it gets tricky. Like you have to know how to find the formulas.
That's fair. I understand. So then going back on that, would you have any other, using this knowledge, would you make any changes to slide 3 then?
Well, again, I don't know what you were saying. I don't know what it was saying on slide 3. I think this is probably the right answer from what I can see. Triangle ABC is a right triangle with hypotenuse of 15 feet. Find the rate of change of the angle that the hypotenuse makes. Well, I can't tell what that says. With one of the legs, maybe between one of the legs and the hypotenuse, when the opposite leg is 9 feet.
I think it says find the rate of change of the angle theta formed between one of the legs and the hypotenuse when the opposite leg is 9 feet.
The rate of change of the opposite. Oh,
so it's
maybe
like
they're saying the rate of change of this leg. Okay, let me read. Maybe. All right, hold up. Let's try this again.
So I think, wouldn't it be like the rate of change here?
Yeah, so I think it was talking about this is 9 feet here. But they were saying find the rate of change of the angle between. Oh, okay.
It does say the opposite leg is 9.
Find the rate of change of the angle formed with the between one of the legs and the hypotenuse when the opposite leg is 9 feet. Yeah, I'm telling you, I think this was the 9 feet. I think that is 9 feet, but they're saying at that point, they're talking about doing it at that point. So still the relationship between X and theta is still going to be the cosine of theta equals adjacent over hypotenuse. So 15 cosine of theta equals X. And if we take the derivative, oh, here we go. Well, yeah, isn't this what I did? If we take the derivative of the whole thing with respect to time.
I think that is what you did, but I think that it's
we would get 15, negative 15 sine theta. Okay, no, I know what to do now. Because yeah, we were on the right track. We just had to plug in theta. Negative 15 sine theta times d theta dt equals dx dt. So, but they said find it when it is when the opposite side is 9 feet. So what angle would this be if that was 9 feet? You would do the sine of theta equals 9 over 15. So theta equals sine inverse of 9/15. Actually, no. All I need is this. So here's my formula, right? And now let's just plug in what we have. Sine theta is 9/15. Dx dt, what did they say that was? 5 feet per hour? Right?
Yeah, but I think that's also on the opposite leg. Because it says the rate of change of the opposite leg.
I know it is, but remember we use this formula with this leg, and then we use they told us at the point of the opposite leg, we use that to come up with the sine of theta. I'm 98% sure that this is correct. Now that I know what the question said. So there's negative 15, and this is d theta over dt. So those cancel out. You get negative d theta over dt equals negative 5/9. And that would be I don't know what the units would be for that actually. Because an angle the change in theta should be in like degrees per hour or something like that. Degrees or radians per hour.
Okay, so the answer would just be negative 5/9 then, like degrees per hour.
Negative 5/9, and I don't know if it's degrees or radians. I'm not sure why I can't think of it, but I don't see units anywhere on this, and I can't think of what the units would be. You've got feet per hour.
I guess, to be honest, this is just my confusion. Then why would 5 feet per hour be paired with x then? I understand the cosine, but I guess just because I can't get opposite out of my brain. So then that's what I kept thinking.
It's the way they worded the question. They said the rate of change of an angle. I mean, we could have put theta here. We could have put theta up there, but then 9 would have been down here. And feet per hour would have been up here. You know what I'm saying? Like we could have done that. but the formulas all would be the same.
I guess, but like since this is known as the opposite leg, wouldn't it still apply to still be considered the opposite leg when referring to
No,
the
they
rate of
didn't
change?
mean the opposite, like opposite adjacent. They meant the opposite leg from the one that they told us in the first place. They meant the other leg. This, think of this as just saying the other leg is 9 feet. And see, that's saying when the other leg is 9 feet. That's like them saying, find the rate of change of the area when the length is 3 and the width is 8. Because remember, this is changing all the time. The length and the width are changing at a rate of 4 centimeters per second and -5 centimeters. So this length is getting bigger and the width is getting smaller all the time at this rate. Do you get what I'm saying? So these things are changing. So in order to find the change in area with respect to time, you need to know what point you're referring to. There has to be like, well, when, because it's changed. The area is changing. It's related. This is a related rate, right? It's changing related to how fast these things are changing. So if you ask me, well, tell me how, if you ask for the dA dt when the length is 10 and the width is 15, that's a totally different answer, because that was at an earlier point when the rectangle was bigger. It was, the area was changing at a different rate than when the rectangle was smaller, or this, like this. Do you get what I'm saying? So what they're telling you here is find the change in the angle when the opposite leg is at 9 feet. So what's happening is this, it's like a ladder. The question doesn't seem to be worded very well, but it's like a ladder, right? This length isn't changing. 15 feet isn't changing, but it's moving down the wall. It's moving like this. So the 15 feet is right here now, right? And then 15 feet is going to be right here. And see what's happening? This side is changing, right? And so is this side. See how this side, if this is still 15 feet, it's not really moving down a wall. It's, the ladder is just, it's like the ladder is anchored at this point, and this edge of the ladder is falling like this. Do you get what I'm saying? So that 15-foot board, let's say, is just free falling in the air. Do you get what I'm saying? So this is anchored here. That angle is changing, but so is this side, and so is this side. This is never changing. 15 feet never changes.
Okay.
But they wanted the rate of change of the angle formed. So that told me that I had to come up with a formula. This is what I was talking about with these problems. The hard part is knowing what the formula is that you need to come up with. Okay.
Okay. And you
So
came up with
the reason I came up with this formula is because I had to relate that angle with this side. I had and with this that I know. These are the three things that I know. I don't have to add this thing in. That is unnecessary to add in. But this is going to be factored into it when I'm trying to find the sine of theta right here. Okay?
Okay. And then I guess just to clear this up, you went
Mhm.
you found the derivative like right here, like in this step right here. But where did you get the negative from?
Because what's the derivative of the cosine?
Oh, right, negative sign. Sorry, that was just
Negative sign. And then there's the
forget.
chain rule, right? You got to keep the d theta dt. And like I said, I'm a little bit, I don't know why I'm drawing a blank at this right here, but what the unit should be. Negative
well,
5/9. Radians. I think it's gonna have to be radians per hour, maybe.
okay. I think, to be honest, it's mainly like the wording that's like really complicated a lot of the time.
You're right. It is, especially when it's really blurry. Do you have another
Yeah.
one?
To be
Or
honest,
can you
I kind of just wanted to go back to the first one and actually review one thing with you real quick.
Okay. The first one of these, or the first?
Yeah, the first slide.
Okay.
I was wondering, I actually had to, I think for, let's just say, because I tried to solve this based on my assumption that this graph was f
The
double
double
prime.
derivative, right? You wouldn't be able to do that.
Okay.
That would not be possible to solve.
Because I tried, but like I ended up finding out that this point would probably just be an inflection.
It would be. And so you wouldn't know the value of that. You wouldn't know the value of that originally from that information. All you would know is that every point on the graph, if this was the double derivative right here, then every point on the graph I'm sorry, then it's concave down here and concave up here. So it'd be, and that would be an inflection point, but that wouldn't give you any information about what the derivative was for that one, nor, well, would it help you with the derivative? Maybe. It certainly wouldn't help you with the actual function value. You would have no idea what the function value was.
Okay.
So yeah, you misinterpreted, but that question is a great question for like the AP exam. This is the kind of thing you'll see on the AP exam.
Gotcha. Thanks. And I did want to ask, I know that like there's a rule that, hold on, let me remember. I think it's, if f of prime of like a number, like let's just say 2 in this case, is if f prime of 2 is equal to 0, and if f double prime of 2 is greater than 0, then f of 2 is concave up and has a minimum at that point at f of 2.
I think so. Say it one more time. I'll write it down.
Sure. If f prime of 2 is equal to 0,
Okay.
and f
That means it's a max min, right?
There's one more like if. There's like 2 ifs.
Okay, but that means f of 2 is a max or min. That's what that means. And what else?
Yeah, is actually no. It means f of 2 is a minimum.
Well, we don't know yet. It's a max or min right now, based upon what you've told me. Now, what else do we know?
And then f double prime of 2 is greater than 0. Great. Yeah.
Okay. That means that f of 2, that f of x is concave up, right?
Mm-hmm.
F of x concave up at 2, at x equals 2, which means, like you said, that means it's a, I'm sorry, you're right. That means it's a min because it's concave up.
Oh, it's okay.
Yep. So together those imply that f of 2 is a min.
Yes.
Yep. Good job.
Thank you. You too. I just wanted to ask you a question though.
Uh-huh.
I think our teacher clarified this, but I just wanted to be sure because if f double prime, I think it was like f double prime indicates when f prime is increasing. Like,
Yep. Yep. F double prime is the rate of change of f prime. The double derivative is the rate of change of the single derivative.
yeah, just like how f prime shows when f of x is increasing, decreasing.
That's correct. Yep.
So, like, I guess.
So in the scientific terms, you'll probably, if you've ever had physics, the derivative is velocity, and the double derivative is acceleration.
Oh, wait. Can I actually write that down?
Maybe I shouldn't say velocity, maybe I should say speed, but from what I remember, it's velocity. I think speed is the absolute value of velocity. Is that right? Are you taking physics?
No, well, one of my friends are, and she's like, and she actually like is in the same Calc class as me, and so like a lot of the time she relates it to that. So
No pun intended.
yeah.
Related
No.
rates. So speed is the time rate at which an object is moving along a path, while velocity is the rate and direction. So yes, speed is always positive. Speed is the absolute value.
Oh, it's the absolute value. I don't know.
Yeah. So no. Yes, and yep, you got it. Is acceleration.
Oh, okay.
So speed is the rate of change of distance, right? Velocity is the rate of change of displacement. And acceleration is the rate of change of velocity. Does that make sense?
Okay. So like then f
So
prime of x would be like
speed. Yeah, exactly. So f prime of x is like velocity. F double prime is acceleration. So acceleration is the rate of change of the rate of change. Like if you're in a car and you're going 40 miles an hour, but your acceleration is 0, then the double drift, then your velocity is 40 miles an hour, but your acceleration is 0. You're keeping a constant velocity. But if you step on the gas, now your acceleration or your velocity is changing, but it's increasing. If you step on the brakes, you're still going forward, right? But your acceleration is negative now because your rate of change in velocity is negative. If I'm explaining that correctly, which I think I am.
Okay, that kind of makes sense. So since acceleration is the rate of change, what is the regular rate of change? Just f prime of x?
No, there isn't. You just said, what is the regular rate of change?
Like, what is the rate of change? Since
the rate of change is velocity. Yeah, rate of change is velocity or derivative. This is the rate of change of the function at x equals 2. That red thing in the middle there. In physics terms, velocity is the rate of change of time, or of distance rather, right? Because when you're driving a car, you're traveling a distance. So it's the change in distance over time. That's why they call it in physics, they call it, I believe they use the S in physics, right? This would be called ds dt, where S is location S is position. So ds dt is velocity. Right?
Okay.
And then
Gotcha.
dv dt is acceleration. You're not taking physics yet, but that's when you do. If you do, that's you'll definitely use calculus in that. dv dt is acceleration, or you could call it ds.
Oh,
dt. That's how they write it, I think. The double derivative. D
oh.
squared s over dt squared is, I think, how they write it.
So then, like, what would regular f of x be then? Like original.
That's just s. That's just position.
Okay. Gotcha. I guess mainly what I wanted to like make sure of was, so if f prime of x is negative, then that means that f prime of x is going to be like decreasing.
That means it's decreasing.
Okay, so just like based on, since like I thought this was the double derivative, that would
Yeah.
mean that right here, f prime of x would be decreasing.
If it was the double derivative, you're saying?
Yeah, if this graph was the double derivative,
Yes, you're
then
correct.
f prime
Yep.
would be decreasing here and increasing here.
Yep, you got it.
Okay.
So there's a table that you'll see sometimes. F of x, f prime of x, and f double prime of x. If this is positive, then that implies that f of x is increasing. Does that make sense? If this is negative, what does that imply? F of x is what?
Is going to be decreasing.
Decreasing
sorry,
at that point. And if it is equal to 0, what is it?
max, min, or inflection.
That's right. Fx max min. Okay. If f double prime of x, if that's greater than 0, that implies that f of x is concave up, and that implies that the double derivative, or the derivative, is increasing, right? Like you just said. Make sense? If it's negative, if the double derivative is negative, that implies that f of x is concave down, and also it implies that the derivative is decreasing.
I guess.
And if it's 0, if the double derivative is 0, what does that mean?
That means like f of x,
Inflection, right? Isn't it an inflection point?
Yeah. I mean,
and that would also imply that the derivative was at a max min. If you cared about the max min of the derivative.
Oh, but so I guess could you also find out the inflection of the original function through f prime of x? Like when f prime of x equals 0, could that be a possible inflection as well?
Is it? Or is it only a max min?
I think it is.
Maybe could not exist.
It could be both, I think my teacher said.
Okay. Well, yeah, let's think of it as a simple example. I don't know why I don't know this, but y equals x cubed. the derivative is 3x squared. And so 0 is definitely not a max or min point. So yeah, you're right. Yep, good.
Okay.
That would be here too.
And
Yep. So that's just a good little kind of note sheet to keep track of. Okay.
can you hear me?
Oh, now I can. I lost you for a second.
Oh, okay. Sorry about that. I just wanted to check and say, that shows that f double prime of x can also like show where the max or min of f of x is, right?
F prime of x.
Oh,
Not the max or min of f of x. No. It's the max or min of the derivative.
okay.
Okay.
Got it. Thank you.
No problem. Have a good one. I will talk to you next time. Okay.
Oh, I did want to check one thing with you. I wanted to